So here we're asked to differentiate something that looks like a product, and then in part B, something that looks like a quotient. So it looks like we're going to be using the product rule and the quotient rule. So let's look at part A. You've got 5x squared multiplied by the natural logarithm of 3x. So you would naturally take the first term to be u, the second term to be v, and then differentiate each of these. So if that's our u and this is our v, then the product rule simply says the derivative of u times v plus u times the derivative of v. And writing 5x squared is straightforward, and log 3x is 1 over x. And if you put that into the expression and then simplify, you end up with that. So that's part A, straightforward. Slightly less straightforward is part B, because we're asked to differentiate it and then show that it's equal to another expression. So we're asked to show that the derivative of this gives you this. And the first thing you notice is that there's a double angle in the formula, a double angle in the denominator. So this is what we're trying to show, but I guess we would start with the quotient rule, because you've got a quotient. So your numerator is always going to be u, and your denominator is going to be v, always, using this formula for the quotient rule. So the derivative of x is straightforward. Derivative of sine gives you cosine. Derivative of cosine gives you negative sine. So if you put those back into the formula, you end up with an expression that looks like that. And obviously you can open the brackets and maybe take a common factor in the numerator, two common factors in the numerator, but the interesting action is taking place in the denominator. So if you expand the squared, you multiply that out, you'll end up with sine squared plus cosine squared, and then sine times cosine times 2. So that's simply by multiplying out the brackets. Now, sine squared plus cosine squared, that gives you 1, and 2 sine cosine x, 2 sine x cosine x. You should recognize that as a double angle equivalent for sine 2x. So that simplifies the denominator for us. It now looks like the denominator we were asked in the question to show. So now we just need the numerator to look like that. It looks like there's a sine and a cosine that's been taken as a common factor. We can do that. So if you recognize there's a sine here and a sine there, you can take that as a common factor. And there's a cosine here and a cosine there, you can take that as a common factor. Obviously, you need to multiply that out, but you can see that negative, you've got a plus x here, and then this negative finds its way to there. And just swapping these around will make it look exactly the way they asked. So I hope you found that